Okay, good morning, good afternoon, good evening, good night, depending on when you're watching the video. This is the last section of lecture set number 2. So I'm going to work through slides 51 through 56 or through 54. Slides 51 to 54, and then the conclusion, which is slide 55. In this last section of lecture set number 2, we're focused on describing the relationship between two variables at the same time. So at this point, we are familiar with how to summarize information from one variable. So for example, if we were given a data set that looks like this, we would say this is a data set composed of two variables. Okay, one is sleep, which is in hours, and the second one is the midterm mark. Okay, we know that both of these variables are quantitative. We would say that sleep is quantitative continuous. And we would say that midterm mark is quantitative discrete. All right. So if we were asked to describe these variables, we know that we can do things like compute the mean, the median, the mode. We can compute measures of spread, so the standard deviation or the 5-number summary. We could build box plots of each variable separately, or we could build histograms of each variable separately. All the tools that we've talked about through lecture set number 2 would apply to each of these variables individually. Now, what if we were interested in actually visualizing the relationship between both variables at the same time? Well, to do this, we're going to use what is called a scatter plot. And to interpret the scatter plot, we are simply going to describe whether or not the relationship is linear and the direction that that relationship is heading. So whether it is positive or negative with respect to its linearity. Okay, a scatter plot for our two variables is shown on slide 53. So here we have our midterm mark plotted on the y-axis, and we have the number of hours of sleep plotted on the x-axis. Each dot on the scatter plot is simply a coordinate. For example, the first point is the point 1.552. So this value here is 1.5 on the x-axis, right? So this would be 1.5, and then 52 on the y-axis. The next point would be the observation 2.245. Okay, so this point here is 2.245. Okay, so every single observation or point on the scatter plot is simply marked via its sleep versus midterm mark value. So these are coordinates. Now, to describe the relationship, what we're going to do is draw a straight line. And we're going to draw that straight line through the points to the best of our ability. Okay, so maybe something that looks like this. Okay. And now what we're going to do is we're going to ask ourselves, does it appear like these points are following that straight line relatively well? And if so, we would say that we have a linear relationship present in the data. The second part of this is whether or not this is a positive relationship or a negative relationship. Very simply, if we increase on the x-axis, so in this situation, we increase the number of hours of sleep. If the midterm mark goes up as the number of hours of sleep go up, that's a positive relationship. If the midterm mark goes down as the number of hours of sleep goes down, that would be a negative relationship. So in this particular illustration, we have a positive linear relationship because these points do appear to follow that straight line relatively well. It's never going to be a perfect fit, But this is clearly not showing us any curvature or lack of patterning. Now, it's also possible to comment on the strength of the relationship. So for example, you could say this is a strong relationship or this is a mediocre relationship, that sort of thing. That does become more subjective. And later in the course, we will develop measures to actually determine how strong a particular linear relationship is. But for now, it's fine to just say the direction and whether or not you think the relationship is linear. Okay, so to summarize, if X increases and Y increases, it is a positive relationship. And here, X and Y just mean the axes. So the X-axis is this axis, and the Y-axis is that axis. So if the value for X gets bigger, and so does the value for Y, that's a positive relationship. If, on the other hand, X increases and Y decreases, it is a negative relationship. If the observations appear to follow a straight line pattern, it is a linear relationship. Okay, so for example, if we have our X and Y axis here, okay, and we have something that looks like this, right? This would be positive linear. If we have our XY axis and we have something that looks like this, okay, this would be an example of negative and linear. If we have our X and Y axis and we have something that looks like this, okay, this would be an example of no relationship, because this is what we would describe as more of a cloud-like shape. There's clearly no pattern between X and Y. So we would say that this is no relationship. Okay, if we have something that looks like this, okay, this would be non-linear. So there's a lot of different non-linear types of relationships we could see. This is an example of a parabolic relationship. Okay, so in that case, they are related to one another. They're just not related via a straight line model. Okay, so our the purpose for studying this is to simply describe the relationship between two variables. When we want to model two variables simultaneously, two quantitative variables simultaneously, we use a scatter plot. When we're describing the relationship on the scatter plot, we focus on linearity, so whether or not the points appear to follow a straight line, and then we can add in the direction, so whether it's a positive relationship or a negative relationship. Okay, lecture set 2 was a crash course in descriptive statistics. So we covered a lot of material in this lecture set, starting from organizing qualitative data all the way up to visualizing two quantitative variables at the same time. Throughout the lecture set, we have examples of how to compute the different measures of spread and center that we studied and described as we worked through the lecture set. So please review those exercises. Please review the information on distributional shapes. In particular, we focus on unimodal symmetric left and right skewed shapes. Those are the shapes you're going to see most often throughout the semester. If we cannot visualize the data for some reason, we can use measures of spread to determine the shape. So if the mean and the median are at the same spot, that's an indication of symmetry. If the mean is larger than the median, that's an indication of right skewness. And if the mean is less than the median, that's an indication of left skewness. As always, if you have any questions, please let me know.